Okay, it's time for node voltage in the phasor domain. So we just did a problem. Well, the previous video is this same circuit, okay, but using mesh current. So here we're going to use node voltage, but it's the same elements. Okay, this guy here is 20 angle 90 degrees volts. This is a voltage source. This is a current source. This is 5 angle 0 degrees amps. We do need an arrow direction on this thing. Let's go that way. Although, strictly speaking, you could get away with not having an arrow direction since you're given this thing. It's weird. It'll kind of works out. But anyway, we're asked to find V across the J4. This is minus J4 here. This guy. I should say V minus J4. The voltage across this thing. So V across the minus J4 element is this thing with this polarity here. We're asked to find the voltage across this cap. Let me put the rest of the values in here. This is minus J8. This is ohms. This is 12 ohms. This is J4 ohms. Okay, great. So we're going to use node voltage. So this is the ground node. This is 0 volts, or 0 angle 0 if you prefer. You could say that, 0 angle 0 volts. So let's see, we're rising from 0 up across this element here. So this is going to be, let's call it V2 for the math, but we know it. We know that it's 20 angle 90 degrees at this element because it's rising from 0 to that, but it'll be convenient to call it V2 in the math, so we have to write less. Let's call this V1 and then call this V0. All right, we name our nodes, right? And what's the method here? We're doing in will be negative, out will be plus, and we're summing I and V over Z terms, right? So yeah, so what's the next thing we do after we pick our nodes? We guess current direction. So we'll guess this way. We'll guess out, guess up. Up is nice because it'll go plus to minus and give us the polarity we want. And let's see, we'll guess. So if this is out, then just to be consistent, this is in, same arrow direction, and then guess that this is out, guess that this is that way. All right, so you guess these guys, then you start writing equations, right? So we've got node V sub 0. So we've got, coming in, we've got 5. So this is it's just 5 real, because it's like this. 5 angle 0 would be just going that way, which is just 5 real. This guy here, this is going this way. It's 20, which is the same as saying 0 plus J20, because it's J is vertical, it's up. So there's that. So this guy, okay, back to this guy. So we're summing the nodes at V0. So in is 5, just plain 5. So it's negative 5 because it's in. The negative is in. Then this guy here, we need a term for that. So if the arrow's going up, which is a guess, right? But if the arrow's going up, then V0 must be bigger than V2. So it's going to be V0 minus V2 over minus J4, the impedance. This is just a V by Z term here, V on the top, or delta V, change in V on the top over the impedance on that branch. Okay, then that was the one going up. The one going out this way is going to be positive, and if the arrow is going this way, V0 must be bigger than V1, so it's going to be V0 minus V1 over minus J8. Okay, and those sum to 0. That was node voltage V0. Okay, we've got V0, V2, and V1. Oh, but V2 is known. V2 is known. It's just more convenient to write it as V2 here. So the only unknowns are V0 and V1. Looks like I need another equation. V1 ought to do it, right? Maybe, unless it introduces another variable, but it won't. So V1 here going in is this dude. So that's negative, and we already calculated that guy. It's this term. So it's going to be V0 minus V1 over minus J8. And then these two guys coming out are going to be positive. And this one coming down is just V1 over J4, right? These are V over Z terms, right? V1, the difference is V1 minus 0 volts. So it's just V1 over J4. That's this guy coming out. Okay, this guy coming this way is going to be V1 minus V2 over the impedance on that branch, which is just 12. And it's positive because it's leaving the node. So these are 0. So V2 is known. I got V1 unknown, V0 unknown. Here I've got V1 and V0 unknown. So there should be a solution in this thing. So let's, get your calculator to do this. Let me do some manipulations here that I would have to do. You may have to do something less or even more than that. But let's get this in standard form so we can solve this sucker. And I'm going to do a couple of funky manipulations. So pull the V0 out of everything that it's in, factor that guy out. So it's going to be V0. I've got a minus J8 and a minus J4. So it's going to be V0 1 over minus J8 plus 1 over minus J4. Okay, then I can pull the V1 terms out. This V1 has a J8 on the bottom, and it's got some extra negative signs you got to be careful with. It's negative 1 over minus J8 because this is a minus V1. There's a minus J. So there's a minus sign you got to account for somewhere. This equals this 5. Pull that guy over to the other side, and seems like I'm missing something. Oh, V2 is known, and so V2 is this thing. It's 0 plus J20, right? Is V2. 0 plus J20 equals V2 here. This thing is same thing. 0 plus J20 is the same thing. So plug that in here, and it's going to have the J4 on the bottom, and then move it to the other side, and this negative sign will go away, and you end up with 0 plus J20 over minus J4. Okay, this is the V0 equation in standard form. So the V1 equation, this equation here in standard form, same thing. Pull out the V0, factor out all of these crazy terms. You're going to get a minus 1 over minus J8. That's it for V0. And then V1 has a bunch of guys. It's got the J4, it's got the 12, it's got the minus J8. It ends up looking like this. 1 over minus J8 plus 1 over J4 plus 1/12. And then the V2 is known. Here it's negative. And then it's got a 12 on the bottom, and then factor it out and pull it over to the other side. It's going to be 0 plus J20 over 12. right? So, we crunch it down so there's not so many fractions. So it's going to be the V0 equation is going to become V0 J 0.375 plus V1 minus J 0.125. This 1/8 here, and these guys are cut to 3/8, 375. And then this thing over here, this becomes, or this equals 5 plus, just rewrite this thing over minus J4, right? Get rid of the 0. And the J's cancel, and you get a negative 20 over 4, which is 5. So it's 5 minus 5 is 0. Weird, huh? But that's what happens. Then V1 is the second equation crunched down. It's going to be V0 minus J125, 0.125. This thing is 1/8. The negative. So the bringing the J to the top becomes a positive J. That's another weird thing that happens. I think that happened on this guy too. Or did it? Yeah, it did. Anyway, then factoring out moving J's up, and they this one becomes a positive J on the top. This one becomes a negative J, and it's crazy. And then the 8th, so the 12th is just a real. There's 1/12, 0.08333, and then these guys here is it's going to be a positive 8 and positive 1/8. It ends up being minus J 0.125. These two terms, those equal this thing here. You're just dividing J20 by 12, which is J 1.666. And if you like polar, which everybody loves polar, or if you like, the full complex number, just like this one over here is 0 plus J0. So yeah, I've got V0. These are complex numbers. Imagine there's a 0 plus J0 and then a 0 minus, 0 minus J 0.125, and expand these into the real and complex components. I'm going to go ahead and do that instead of just saying that. So the V0 guy is V0 0 plus J 0.375 plus V1 0 minus J 0.125 equals 0 plus J0. And then the V1 equation becomes V0 0 minus J 0.125 plus V1 0.0833 minus J 0.125 equals 0 plus J 1.666. Okay, now if you have an HP28S like I do, I can put this into a matrix. So the matrix V0 over V1 will be given by these coefficients over here in a matrix. So it's 0 plus 0J over 0 plus J 1.66. That's these guys over here in a matrix divided by these 4 complex number coefficients in a 2x2 matrix. So it's 0 plus J 0.375. Yeah, that's one complex number. That's this one. Then this one over here, 0 minus J 0.125. These two guys here, 0 minus j 0.125 and 0.0833 minus j 0.125. Okay. Now I can punch these into my, Ross's ancient calc. Your results may differ. You may be able to enter this in your calculator and get a result. You may be able to enter this. You may have to go all the way down to a matrix. So I'm doing all of these steps for you, but you may be able to take some shortcuts depending on what hardware you have. The answer is going to be this matrix, which is minus 2.66 plus j 1.33. That's V0. And V1 is minus 8 plus j4. Woohoo! Okay, so now we can solve for V minus 4j, the voltage across this minus 4 guy. So this V minus 4j is just the difference between V0 and V2, right? It's just V0 minus V2, right? Because this has some voltage and it's dropping down to this where it's less. So it's going to be this one's bigger than this. That's what our plus minus polarity tells us. So it's going to be V0 minus V2. So V at the minus J4 equals V0 minus V2. It equals V0 is minus 2.66 plus J 1.33 minus V2. Where's V2? Over here. It's way back over here. That's 0 plus J20. Yeah, so add up the real parts. So it's minus 2.66. Add up the J parts. It's going to be minus J 1866. 20 and 1.33 gives you 18.66. That's the answer in rectangular format. You could punch the polar to rectangular conversion button on your fancy calculator and you would get 18.86 angle minus 98.108 degrees volts for V minus J4 is the answer. Right? Conceptually, not too bad. It's just node voltage. It's just we've got all these complex numbers to deal with, which makes the math tedious and error prone.